All right. So this is what I want to talk about. It's called a smoking machine, which literally smokes. Is a machine that smokes cigarettes, and I think it can be adapted to smoke other things too. It's really it's a very interesting device. It's robotic, quote unquote robotic, which means you load up. Let me see if I can zoom into a picture. Looks like it's zoomable. Let's see if I can look at the entire, the whole machine with more details. So I can show you the parts. And I'm using this as an example of systems development, information system development. Because up until now, when we talk about information systems, we're talking about banking, libraries, your really typical I don't know where the server is and they don't really care kind of application. And also we're talking about communication through the network. We're talking about regular users like you and I, using Amazon to buy stuff or using the ATM to draw money and stuff like that. But I would say that this is an information system as well. It's just not your typical information system, but it still shares a lot of the common things that we have talked about already in the development of the software of a system like this. So I'll just kind of briefly describe what it is, and also the different parts. This little slide thing here, it doesn't zoom in anymore. Okay, this slide thing here is a magazine of cigarettes. So you load it up with lab quality cigarettes. So this is not the kind that you buy from a store, because the kind that you buy from a store, even with the same brand and the same how do you call it? It's not model, but it's the same brand and the same kind. The composition can change over time. So it's not really good for lab uses, because for lab use, it has to be very consistent across time. So that's why you have to buy these really quite expensive lab cigarettes, load up the slide, which is the magazine. So you load it up with this, so you can actually load it up all the way up to here. And then this is a pneumatic plunger. You basically have pressurized air going in this end and also this end. So you can basically control whether you're inserting a rod into this whole thing. So you push the cigarette into the, this is a carousel. In other words, it's a wheel with holes already drilled, and you can push a cigarette into those holes, and then rotate the wheel to another hole, and then load it up again, and so on. The top part here has a little tube that connects to an air pump, and the air pump is what is going to quote unquote inhale the cigarette. So it's going to do the puffing action. And over here is a little lighter. It's an electric lighter to light up the cigarette. So the whole thing can be fully automated. It can smoke up to 10 cigarettes at the same time. Okay, and yeah, it's really quite interesting. The control unit is down here. This is actually a picture of the very original design control unit, which has almost no user interface whatsoever. It's just a few buttons and 2 LEDs, and that's it. And that's it. This is the whole system. Why do you think this is an information system? What is it taking in, and what is it controlling? What is the input and the output of the system? Cigarettes and smoke, right? Yeah. It takes cigarettes in and it generates smoke out of it. Yep.
And then it probably analyzes how many times it takes to finish one cigarette, like how many puffs it takes. Because you say it controls the in and out air, so that means it's probably testing that too.
Actually, it doesn't have that type of sophisticated measurement.
I'm just saying
it could. It could. Yep. All it really does is just smoke the cigarette. It doesn't really care whether it doesn't even know whether the cigarettes are lit correctly. But since this particular model, the hardware has not changed over the past I think from '98. So the past 14 years has not changed. The control unit, which is this little panel here, has gone through 2 revisions. This is the original revision. The second revision, I kind of made it out of existing parts, and then the third one, I actually custom designed a printed circuit board to do it. So in the latest revision, it is the user interface It's also just as simple as this one. There are no LEDs whatsoever on it, but guess what? It's Bluetooth enabled. So now a customer just walks up to it, and get a Bluetooth connection, and now you just have to run the dumb terminal program, and it has its own text menu and stuff like that. So you can set up how many cigarettes to smoke, how often to smoke. You can set up like on and off time durations, because this is intended for labs. So some labs only want to run the smoking machine on certain hours of a day, for so many hours. So it has all that abilities too. If you have a remote control PC with a Bluetooth dongle on it, you can actually remotely monitor the progress of the smoking and so on and so forth. So it's really quite interesting. So before I go any further into the information system aspect of this thing and the design process, can anyone think, why do we need smoking machines? Because it's too hard to inhale myself. Yep.
Is it to process the data to see how it affects like the lungs and stuff?
That used to be the purpose. Okay, that used to be the purpose, is to find out how damaging smoking can be. So they feed the smoke into a chamber with animals, and then they expose the animals to cigarette smoke basically, and then they dissect the animals later and find out how smoking affects the animals. So that's what it used to do. But these days it's actually not used for that purpose anymore. A lot of pharmaceutical companies buy these type of machines, and also researchers buy these type of machines to research and find out the efficiency or the efficacy of various drugs for treating lung-related diseases, okay, breathing related diseases, because they found that they can try many different ways to induce breathing problems and lung problems in animals, but the most cost-effective way to induce problems in lab animals, guess what, is smoking. Yep. So as it turns out, cigarette smoke is the most cost-effective way to make lab animals sick, with breathing problems and all sorts of other things. So this is actually the machine to make animals sick to begin with. Then they can give medication to the animals and see whether the medication helps or not. And that's basically what these machines are used for these days. Okay, now taking a step back and think about this. What would be an actor? Remember in chapter 10, you learned about the UML, the use case diagram. And in the use case diagram, there are matchstick figures to represent quote unquote actors of an information system. In this case, who is the actor? The end user, right? The end user, which is probably a graduate student working in a university or a researcher in a hospital. Okay, so that would be the matchstick figure. The actor is basically the operator of a machine like this. When you think about a machine like this, do you think the user interface design is important? It is. It's very important, because people who operate a machine like this, they don't want to use a dedicated PC with a complicated screen to control everything. They just want to load up the cigarettes, program in the number of cigarettes to smoke, and how often, and then just let it run. Okay, so that's the user interface. What about the development of a system like this? So we are done with the user interface design, which is fairly simple and fairly simple. What about the actual development of a system like this? Now this one is very different, because it doesn't involve just software. It also involves hardware. I had to design a custom printed circuit board just for this, because existing products that I can purchase just cannot get a job done not effectively. So I had to design a new printed circuit board, and also I also wrote the program that ran on the processor of something like this. This would be a very good application for, remember we talked about the Raspberry Pi? This will be a good, really good application for it. The processor already in it cost me about $12 each. So it's not really that far away from 30-something dollars. I know, it's only about a third of it, but in terms of capability, the Raspberry Pi can do a lot more than the processor that I put into it. So if I have to revise it again, and make the next generation, it's going to be a Raspberry Pi, as a controller. So that way I can put Linux on it. It'll be Wi-Fi capable, and it becomes its own server too. So I can do a lot of stuff remotely, in terms of controlling it, monitoring it, and also I can put on a lot more devices because I have a lot more processing power to deal with it. So this is one project, and Becky is here. So let me ask, see whether she wants to do the evaluation first or do it, at the end of the class.
It's up to you.
It's up to me?
For a little bit until you have a good break.
I can take a break right now. I mean, you guys can do your evaluation. I just have to remember to take my sweater. It's not that cold to me.
Okay, we do peer evaluation
Oh, stop the
of all
recording.
professors and instructors